Hi, here I am again, and as you may saw in an earlier video, I got a bunch of these e-ink displays that were in some supermarket and for the prices. Here, for example, Persil, so wash machine stuff, and they are original from Samsung. Here is a little bit close-up view, and I will talk a little bit how to connect them to an Arduino or some microcontroller. This is my first resoldered one, and it's very tiny, but it is definitely possible. There. And the original chip is desoldered. Yeah, here is a working one with a clock, and if I press on the touch button it will go out of the sleep mode, and if I open the case you can see a little bit more of it. Internal is one of these fitness tracker, and the vibration motor and the battery, and also the e-ink PCB. And the USB plug is to program it over SWD, because it's an nRF52 chip, and yeah, that will stay there. I got a little bit of hardware to show this to you. For example, this Knipex, I don't know the word. That's really good for this tiny copper solder wire. And yeah, let's open one up and start from the beginning so you can see how it is possible to open them and to use them. First I will remove the batteries, they are inside of it. And the good thing about them is they are not glued or so, they have these little plastic tips. With them it is possible to open the case without damaging anything. And yeah, let's try it. So now the case is open, and also we can take out the display itself. You can remove the front cover. I think it looks a little bit nicer without it, so you can see more of the display. And here's now the original Samsung chip. It's pretty hard to see, but we can try. So it's a Samsung SEM9110 and one power regulator chip, the oscillator, and the antenna for the Zigbee. The Zigbee connection. Here's the ZIF connector. We can get the display out, and because I need to desolder the Samsung chip, I need to remove the display one time so it doesn't get a heat damage, as you can see on this one. Here is this tiny black dot. That's exactly where the chip is, and while I'm heating it up it got a little bit damaged. That's the reason for this dot. For this I use my knife and pull it to the bottom very slow and with a little bit force behind the glass and in front of the PCB. There are two glue stripes, and I'm hoping that I don't damage anything. using right now, it is not so easy to do. But when I do it slowly, it should work fine. So, and while I'm recognizing that it gets a little bit easier to push, I remove a little bit of force so that it doesn't go hard to the bottom if the glue tape is over. So as you see now, it is open, and here is one glue stripe and the other one, oh, okay, in this case it's only one glue stripe, but it is now from the PCB removed. Here you can also see the NFC antenna, but unfortunately the hardware for it is not connected on the PCB. That's these good pads, so it is not usable. This is the back side from the e-ink display. Here are a little bit data of it, and I didn't find much of it on the internet. Also important is this description on the flex cable. That is a more important one. Here I also got a display with the red inside, and I removed it while it was refreshing, so there's a little bit left from the text. And there's also the text on the PCB on the flex cable, so like this. Okay, but first I will show how I remove the chip, and then I will show how I solder the cables directly to the pins. And on this already done one, you can see where to connect and where not. I will need to, okay, if the focus is working, I will need to connect multi and clock from the SPI, and that is directly connected via the PCB traces and is pretty easy to solder. The other thing is the control wires that I need to go here, and that are four pieces, 4 cables to solder. If I find it, I can show another one. Yeah, that's here. That's how I will do it. I will take some pin headers and solder 2 of them to the minus pin and 1 to the plus pin, where originally the battery is connected. And so I have a very stiff option to plug my cables in, and also the case is pretty rough, so it's possible to reuse the case but have the controller outside of it, so it's better usable. Okay, so now I need to get the hot air station. Okay, that is the hot air station I'm using. It is a 858D, and you can find it on eBay for around 30 bucks, I think. In Germany it's 25 euros, and for me it's pretty good. I can use it and I haven't got any errors with it, but you never know. Be careful using them. Don't leave them unattended. First I will go to about 340 degrees. It's just that I'm comfortable with it. And as you can see on my desk, I'm destroying it pretty much, but I'm okay with that. Let's get it a little bit closer. And I'm now just heating up the PCB where the chip is. And yeah, it's just my technique. You can do it how you want it. I need to wait a little bit so it gets successfully reflowed. But when it's liquid, the solder, I will get the chip easily off the PCB. So like this. Now here's the chip, and I will also remove the oscillator and some other spare parts. Like this. And now the okay, I will remove the connectors also from the batteries, so it's easier for me to install the the pin headers. So like this. So now they are all removed, and that's it for now. I should not need the hot air station anymore for this one. Here you can see a little bit closer that the chip is now removed, the oscillator and some other parts. The good thing about this PCB is that the power consumption is nearly zero when the display is in sleep mode. So if I, or on this one where I had my own battery inside and so on, I cannot measure any power consumption of the display after it refreshed. It's just not measurable with my multimeter, and that goes to 1 microampere, I think. Okay, now let's put the soldering station away, also reflow station. Okay, here's now the PCB, and I will show it as close as possible. Also, I will put away the old part that I don't need it anymore. And I will show you where I need to connect the cables. So you can see it pretty good on this one. The last one that is here connected, this one is not needed anymore because we can also solder it directly from this pins. So it's a little bit easier that you don't have to do 5 on this connector and only 4. And we need, oh man, the focus is really bad. Okay, let's do it this way. We have this pad, but that is the one we don't need here. We need the 4 ones after it. So this, and this one. The first we need is the one with the via, and then the 4 after it. There we need to connect these copper wires without any bridges. And you may have saw it in my other video, I don't like flux that much, but in this case it isn't. You can do it without it, so it's pretty hard to do. I have for once this copper wire that is very thin. I think it's the 0.1 millimeter, but I will use this type. It's 0.2 millimeter. It's not so easy to solder, but it's a little bit stiffer, so it doesn't break that fast. And also, don't buy these things. There's always this glue inside of this roll, but it is glued so much inside you can remove more than one turn on this part of the whole spool. It's just to buy it, to sell it. And also just one line of copper wire. You can see directly under it. It's just, yeah. I mean, it's cheap, but it's not the best thing. Buy on your local electronic shop this type. Okay, I will now start to solder, and I hope it's good to see for you. Here I have my ERSA MS8000 with just a normal tip, and some of these gold thing, I don't know the name for it. don't know the name for it. Yeah, okay, let's try it. First I will tin a little bit of the copper wire, and after that I'm going to tin the first connector on the PCB, and I will start on one side and go to the other side. So I'm counting now 1, 2, 3, 4. So these 4 are needed, and I don't know how this will work, but let's see. Okay, that was better than expected. You can see that one wire is successfully on its place, and even without the flux, so maybe it will work without it. I'm also gonna rearrange a little bit the cable or the wire, so it cannot get any connections between other wires. After I solder one wire to it, I will cut it somewhere for the needed length, for example here, and will tin the next wire on the spool. Like this. This is now getting a little bit harder to do because the wire next to it is already soldered. Okay, but that seems to be okay. Yeah, that doesn't look bad. I'm also going to bring it behind this conductor and rearrange it a little bit. Like this. And now I'm also cutting the rest of it, so I can use the spool again. I will tin again the end. And luckily there are only 2 left. Okay, that looks good. Now I will go the other way around this inductor and cut the end of the wire again at the right length. And retinning it like that. And also I'm gonna solder it to the pad. Okay, that's also done. Okay, I'm inspecting it right now a little bit more to see if there are any misconnections, but it looks very good. Better than expected. Yeah, it's also a good connection. It don't go anywhere. And now the hard part is done, and I will need to connect the SPI function selection pin here to the right, to the minus, how do I say it? I need to connect the SPI mode pin to the minus pin of the PCB. So in the middle, this big blob is the minus pin, and I need to connect the fourth one. I think it's this, but it's not so important. I will show it in a minute. First I need to find the right one where I have already done it. Okay, here you can see it. So there in the middle is the blob, and the fifth one from the upper part I need to connect to the middle, to the ground pin. So yeah, now it's correct. I'm just retinning the end of it, getting the spare solder away, and I hope you can see it. Like this. And now I need to connect it to the middle pin, or to the middle pad. Okay, it was now getting away. Just reconnecting it. Like this. So now you can see the fifth pin is connected to the pad. Yeah. Okay, I will remove the excess copper wire like this. And so the most part of it is now done, so the hard part, I can say. I will now take these pin headers and make a stripe like here and solder it to, for once, the minus pin and the plus pin, so it's easier to get a cable on it. So I will do it if the camera is focusing. I will do it like this. So the trace of the positive rail is here, and I will remove some solder mask to connect it directly there. I will leave 4 pins here for the control wires, and 2 pins are then for the SPI connection for clock and MOSI, so data in. So I'm removing the excess pins from the header, and also I'm gonna scrape away a little bit of the solder mask with an X-Acto knife, or in German Cuttermesser. There you have to be careful to not remove some solder mask from the place around it, because then there is an easier connection, or you will get an easier connection to the ground, and it will be a Kurzschluss. So now I'm also tinning a little bit the new created path, and on the pins I'm doing it also. So here I need the 5th and 6th one, so these I'm tinning a little bit, putting it to the right place where I want to have it, and reflowing the solder so they are connected like this. Then I'm also doing the 3.3 volt rail, and after that I'm gonna put more solder onto the minus, to the ground plane, so it will get a little bit stiffer. Okay, I'm also tinning a little bit every pin, so it's easier to connect the copper wire to it. So there's also some flux on it, because in the solder there is flux inside of it. Okay, I now need to search for the first pin I did, and it is this one here, because I will make them in the right order from the connector here, so I know exactly where which pin is. I'm just bringing it a little bit in the direction, cut the excess wire and retinning the end, and then connecting it to the pin header. Like this, and I'm bending it in the right direction, so yeah, I know you didn't saw it. I will try it the other way around. So if I'm now retinning it, I can connect it like this. Okay, then I will do the same thing to the other 3 left ones. I will try to do them all at once. Let's see how that goes. So like this, and then retinning or tinning every end of it. Like this, and bending them to the right direction. Okay, then I have to, that wasn't good. I didn't wait it long enough to, so that the solder is already hardened. The other one and the 4th. Like this. Okay, that doesn't look too bad. Okay, now I need to connect the SPI data in port or pin and the clock pin that is nicely labeled on top here, and you can think about as this is clock and this is MUSI, and the other ones are also labeled. And yes, I did test some variations. For example, here is a UART, RX and TX, and I connected an USB to UART connector, but I don't get anything out of it. Only if I connect the test pin to ground, I think, then there's super strangely there's coming something out like T time, a text where stands T time. It's not so, it's strange. I think it's an Easter egg or so. Yeah, but because we have desoldered the chip, there's nothing nothing happening anymore on it. And I will use the copper wire I cut away from the excess here, and my arrangement is that I will use the clock on the far left one and the data on the third one. You can do it however you want, but that's my style of doing it. I'm now retinning the end of one of these copper wires, and directly will connect them or it to the third pin. Like this, and one is left. Okay, and that is a clock pin for me. Like this. Now I arrange it a little bit on the PCB so the case doesn't destroy anything, and we'll lay it to the data pin in this case. We'll tin the end a little bit like this, and also we'll pre-tin both of these pads. So that's better. Now I'm just soldering it together, and the text is all the ground plane, so you have to be careful not to solder it directly to the ground plane, because then it would not work. I'm bending the clock pin also in the right direction, tin the end of it, like that, connect it, yeah, and I think this part is done. I will get the camera a little bit higher. You can see now all the dirt, but it's okay, it's not so hard. Now we can reconnect the display itself. Just pull the zip connector up, put it in until it is all the way in, and because the glue on the other side is still there, it will just stay in its position. Just align it with the color like this and press it a little bit against the PCB. Now it's a nice flat yeah, thing, nice flat display, whatever. Okay, the next thing I want to show it in function or running. I will use an ESP32 for it this time, because I can use these jumper cables to connect it from this pins to this pins, and I will talk a little bit about it. For this I will make a little bit more space. Okay, before I connect any cables to it, we need to talk a little bit about the library I'm using. It's I will show it on the PC. It's the GX EPD, and it directly works with these displays, except that these are not the ones that are described in the library. I will try to explain. These are the 2.9 inch versions, and this exact display is in black and white, but it is also, I will show it here, they are also available in red, black and white. And after I try to run them, here is the list of the supported ones, and first I thought, okay, it's this one with black and white, 2.9 inch, but it turns out that this display out of the price tag is a version with red, black and white, but red isn't there, so it's hard to explain. It's just connected in another way, and everything that you would write in red on the original or the other display with red is here black. So if you try to write something in black, it doesn't get displayed on it, but if you do it in red, it will perfectly come out in black. It's hard to say. Also on these displays is a corner around this whole pixel matrix. You can see the thin line around it. You can turn it to black or to white, but in the original GXEPD library this isn't supported, and I wrote my own function for it. So because every time I put something on the display, the border was all the time black. So here I have an example with the border set. There's the border around it, and it doesn't look that nice if you don't want to have the border. But I will show you the function and also will link it in the video description so you can build it inside your library. Okay, the next part we have to talk about is the pin out, and for this I'm having the wave share schematic of the black, white and red module, the 2.9 inch one. And if we look at the display and also at the PDF file, we can see this connector here. It has 24 pins, and here on the PDF file there are also these 24 pins, and they are exactly the same on this one. For our for the display we need 6 connections. I'm already soldered them to the display, and I will just go through them. You just need to know the numbers or the pin definition. So we have the buzzy pin, we have the reset pin, we have the DC pin and the CS pin for the SPI bus, and also on these pads there is the data and the clock pin for the SPI bus. You just have to define the right pins in your Arduino sketch, and for this I'm showing you my Arduino sketch I'm using. And here on the top you can see the SPI definitions. The CS pin is 5, or in this case the SS pin. It is a chip select pin from the SPI bus itself, but you can also just put a pin number here. Then you have the DC pin and the reset pin, and also you need to define the display, and there you have to define the buzzy and the reset pin also. I'm using these pins because on the ESP32 the SPI bus the SPI connections are all on this side. On this DevKit 1 do it. It's just you know, there are pretty much of these boards available. I'm using this for this example, but the SPI bus is on this side, and there I'm also connecting all the other pins that are needed, and I will just connect them right now so we can see a working function or a working display. I have 2 4 pin headers, whatever you call them. I will plug them into the soldered pin header bar, whatever. And they are new, so they are a little bit hard to press in, but they are now at the right place. Then I will connect the other 4 pins. because we use 2 pins for the ground connection, we can just leave one unconnected, and yeah, so it's just a little bit stiffer and the place was nicer on this position on the PCB. So like this, there are now all 8 connected, and I'm doing or going to connect the other side to the pin header on the ESP module. So for this I'm just looking what pins are where, and blue is in my case ground. Then we have the data pin. I have to look it up every time I'm doing this, but I have a shortcut of the link in my computer, so I will just look it up. And here's a pretty good description of the pinout. Here is the data pin we need, so the GPIO 23, and we also need the clock pin, that is pin 18. And we are also using the UART 2 pins. I will try to show it here. They are not described as the pins, but at TX and RX2, and I have to look it up which pin of it is the right one. But you will see it on your own board better. So now I'm connecting the data pin to 23, and the next one is the 3.3 volt pin. I'm just connecting it to the 3.3 pin, and then there's the clock pin, that's 18, and then are the data lines. And here it's now easier because I had done it in the right direction, so I just can look up the waveshare PDF file and see that green is, in this example, the buzzy pin. And if I look in my sketch, buzzy is number 4, so I'm just connecting it to the pin 4. Next is reset, that is pin 16, and this is one of the UART2 pins, so it is in this case the RX pin of the ESP module. Then the next pin is the DC pin, and that is on pin 17, that is a TX from the UART. And the next pin is the DC as CS, this chip select pin, and that is connected to pin 5 of the module. So I'm pushing them a little bit more into it, and now we have a connection of these 8 cables, and I will plug the USB in. I think there is already the sketch on it, but yeah, let's see. I'm connecting it. The computer is recognizing the ESP board. Okay, but it doesn't seem to be compiled or on in the chip, so I'm doing it right now. For this I'm selecting in Arduino the ESP32 Do-It board. It's here. Then I will also select the right COM port, but this is already selected. Yeah, and then I hit upload. This example is pretty simple. It's just the display definition. We have a UART port and give some info out on it. We have the debug enabled on the display library. Okay, that's another function I've set by myself, that I don't have the black, white and red device, but I have the other display, the strangely not red display. But that's not so important to use this. that will just invert the whole display. Yeah, okay. So then we select the font and the rotation of the display, and in the loop is just that we display the current time and some text on the display itself. Now the compiling is done and it will upload it to the display, and we will wait for it to show it. Yeah, but as you see, the rotation is the wrong side, but that's not so important. So the important part is that the display is working and refreshing as it should. In this example, also the border is set every time to be present or not. So now the border is away, and the next time the display will show the border, so now it is set. It looks like, if you look very close onto the border, you would think that this border is in reality just some matrix, but unfortunately not. It's just the honeycomb that is used for the e-ink matrix. Okay, but you saw now that it is working and how I solder it. It is now also possible to put the display back in its case, and I will just do it right now. And for this I need to put the cover back on. Like this, and the connections fit perfectly onto the battery cover. Yeah, so that's it for the display connections. I will now also show the modifications I'm doing, or I did, for the display library to get it to work correctly. Yeah. Okay, I'm trying to explain it as well as I can. So for once I added into the display file that is under this path. It's hard to show. I need a screen recording program, but okay. In the library there is a file or a folder named after the display we are using, and in the H file we need to add two new functions. For once the set border function and the set black, white and red function. So that is for this, and in the CPP file we have to add these functions. So in the H file this is just the definition of it, but in the CPP file there is the correct function, so the real function. Here I have added the is border function or set border function or the set black, white and red function. It's just an boolean that is set to true or false, and this is then also used in the wake up function of the display. We also need to define the two booleans in the file, but I will put it in the description a little bit better. So here we have the black, white and red boolean. If it is true, its initialization data is different to the display controller. In one case we send an 8F hex value or a 9F hex value, and in the border part we send a 77 hex or a B7 hex. It is very good described in the PDF from the display controller, but that's not so important for you. You just have to add these functions or add my code to your library so you can use it. And yeah, that's all. Okay, so I hope this was informative for you. I do really like these displays and the case because it's really tough and really rugged. And yeah, if you ever have the chance to get some of these displays, or maybe complete different ones, they are also available with just numbers, so no matrix, but the 7-segment display type ones. They are not so interesting, but also nice. So yeah, you have. If you ever had the chance to get it, just buy them or wherever you get them from. I bought mine from eBay for around $2 per piece, and yeah, I'm happy that they are working that great. Okay, that was it. I'm done. This was longer than I would think. Bye.